Hey guys, hope you're having a good Monday morning. We are on our week 2 with our cover sheets. Those have been posted online, as well as you can pick them up at school from 9 to 11. We also have, did I already say this? We have a new note page, okay? You can find this online to print, or you can pick up a new note page at school. It's up to you, whatever is easiest for you. If you don't have a textbook, you need a textbook, come and get one, email me. I'll make sure there is one ready for you at the office. And I guess here we go. Okay. Okay. So, we are going to be talking about square roots, okay? So square roots are what our focus is, but there's also cubed roots, fourth roots, fifth roots. They're called radicals. So a square root is a radical, okay? There's also cubed roots, fourth roots, fifth roots. You can have all different kinds. We're going to focus on this one, a square root. Okay, so to understand a square root, you really have to understand what a square number is. Okay, so a square number is a number that can be expressed as a square factor. Which is basically saying a number times itself. So an example of a squared number is 2 times 2, so the squared number would be 4. X times x, so the squared number would be x squared. So it's anything that can be expressed as a squared factor. 2 times 2, x times x, 5 times 5. Okay? A square root, okay, is an inverse of a square. Of a square number. So if you remember inverse means like opposite. So opposite or inverse of addition is subtraction. The inverse of multiplication is division. So it's one of two numbers of two equal numbers or factors. Okay, factors are numbers that make up, smaller numbers that make up a bigger number. So 2 and 2 make up the bigger number of 4. Okay, so one of two equal factors of a number. So if I looked at the square root of 4, it's made up of 2 and 2, two equal numbers. The square root of 4 is just 2. Okay, if I looked at the square root of x squared, that's x times x. So square root of x squared is x. So a squared number is two things multiplied that give you a number 4, and a square root takes that number and splits up into two equal numbers and says, okay, square root of 4 is 2. We should be fairly familiar with these. What are going to have you do on this table is fill out the squared numbers and the square root numbers. Okay, I will fill this all out as well, but so like 1 times 1. Squared means multiplied by itself. So 1 times 1 is 1. The square root of 1 is also 1, because 1 times 1. 2 times 2, or 2 squared, is 4. Okay, what is the square root of 4? Well, that's 2. Okay, if you notice, it just gets us back to what this number was that was squared. So 3 squared, 3 times 3 is 9. So what's the square root of 9? Well, that's 3, because 9 is 3 times 3. There's my pair. Okay, so pause the video, go ahead and see if you can fill this out, and then hit play and make sure you got them correct. because I'm not going to pause. I'm just going to keep filling this out, and then you could check it later. So 4 times 4 is 16. Square root of 16 is 4. 5 times 5 is 25. Square root of 25 is 5. 6 times 6 is 36. The square root of 36 is 6. Again, you should be seeing a pattern of pairs. 7 times 7 is 49. The square root of 49 is 7. 8 times 8 is 56. Sorry, is 64. That's awkward. And then the square root of 64 is 8. 9 times 9 is 81. Square root of 81 is 9. 10 times 10 is 100. Square root of 100 is 10. 11 times 11 is 121. Square root of 121 is 11. 12 times 12 is 144. Square root of 144 is 12. 13 squared is 169. 169 equals 13. 13 and 14 is nice, because if you know 13 is 169, 14 is just simply 196. They switched positions. So 196 is 14. 15 times 15 is 225. Square root of 225 is 15. Okay, this comes in really handy. If you're not very familiar with your square roots, these are the most common ones that you see. Okay? So if we think about it as a table of squares, if I had 5 times 5, if you think base times height, there's 25. So 5 squared gave us that 25. It's kind of why they think of it as a squared number. So if you had 5 equal cubes here and 5 equal cubes here, and you had that all filled in, you'd get 25 cubes. So same thing here. If I had 5, 25, when we take the square root of 25, we're saying, okay, what's one of these side lengths? Well, that's 5. So that's the root of the square. Okay? If I had x squared and x squared, what's x squared times x squared? Well, if you remember, you add the exponents. So this is x to the 4th. So x squared is x to the 4th. That is a squared number. Okay? X to the 4th is a squared number. So if I had x to the 4th, we know that was x squared, x squared. If I take the square root of x to the 4th, I get this x squared. There's my pair. There's the root. Okay? We're going to take this nice and slow. They can be kind of confusing to start with, but we will be able to get it. So what we're going to do is we're just going to look at some basic rules for simplifying, and we're only going to be filling in these first 2 boxes today. Okay? So simplifying radicals. What we want to do is we want to factor all numbers and variables. Okay, when I say factor, I want you to break it down into its smallest numbers. So break it down. So like 4 gets broken down to 2 times 2. So you're breaking it down. That's our first rule for simplifying radicals, or simplifying square roots. So if I had the square root of 108, well, first thing I'm going to do, 108 is not in my list of squared numbers. So these are perfect squares right here. 108 is not there. So I'm going to break 108 down. So I want to know what multiplies to 108. I don't know that off of the top of my head. So I'm going to start with 108. So I'm going to grab my calculator. And I'm going to say, let's say 108 divided by 2. Well, that's 2 times 54. 2 is what we call a prime number. It's as small as it goes. The only thing that multiplies to 2 is 1 times 2. Okay, so 54. Let's divide that one by 2 as well. That's 2 times 27. Well, 27 does not divide by 2, but 27 does divide by 3. So that's 3 times 9, and 9 is 3 times 3. Okay, so square root, we're looking for 2's, right? 2x squared, 2 5's, we're looking for pairs of 2. So, sorry, moving around a lot. If you notice, I've got a pair of 2's right here and a pair of 3's. Okay, so if you did on your calculator real quick, so this 2, 2, 3, 3, 3, this is what we call a prime factorization. These are all prime numbers because nothing else multiplies to them but 1. And it's a factorization, meaning that these are all the smallest little numbers of 108. So if I did 2 times 2 times 3 times 3 times 3, so my 2 2's and 3 3's, I'd get 108. So this right here, these small numbers actually multiply to 108. So I've got 1 pair of 2's and 1 pair of 3's. So those are my side lengths. But this 3 is left inside, so we're going to put square root 3. So then 2 times 3 is 6 square root 3. So my answer of the square root of 108 is 6 square root 3. So then if I put 6 square root 3 in your calculator, oops, 6. Okay, that gives me 10.39. So then if I took the square root of 108, that's also 10.39. So square root of 108 is 10.39, but we usually don't like this decimal because it's not very exact. It's not very accurate because we have to do rounding. We don't want to write this whole thing out. So 6 square root 3 is what we call a simplified square root. Okay, I know that was pretty intense. Let's try another one. I'm going to switch colors because I don't have a lot of space here. So let's try the square root of 50. Okay, can you see that one? It's okay. So this one's in purple for me. So we're just going to break the square root of 50 down. So that's 5 times 10 and 5 times 2. So always start with your prime factorization. 5, 5, 2. 5 times 5 is 25, times 2 is 50. So there's my prime factorization. Here's a pair of 5's. So I have a pair of 5, so 1 5 comes out, and I have a 2 left. So 5 square root 2 is my answer. I'm going to check that. I'm going to check that. Square root of 50, square root of 50, 7.07. 5 square root 2, 7.07. I could always check my answer to make sure I'm doing it correct. Okay, let's look at one with numbers. I don't have a different color. Okay, let's try this pink. Or with letters, variables. Let's say I had the square root of y to the 13th. And I guess you guys can see that. So if I break this down, how many 13s how many y's are there? There's 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Y to the 13th literally means I have 13 y's being multiplied together. Square root, squares meaning two sides. Okay, if you square something, you're timesing it by itself. So let's look for our pairs. I have 1, 2, 3, 4, 5, 6 pairs of y's with 1 left over. So I have 6 pairs of y's, 1, 2, 3, 4, 5, 6, and then square root y left. Anything that's without a pair is left inside our square root. Okay, and then if I have 1, 2, 3, 4, 5, 6 y's being multiplied, that's y to the 6 square root y. as our answer. Okay? Sorry, I should have not used that color. So our answer is y to the 6 square root y. Okay? So that's just a simple simplification. Okay? Looking for pairs. Square root means pairs. Find all the pairs. Each pair, so 1, 2, 3, 4, 5, 6 pairs of y's means 6 came out. Okay? On this one, I had 1 pair of 2's, 1 pair of 3's. 3 was left inside. This one I had 1 pair of 5's, 2 was left inside. So 1 pair of 5, 1 5. 6 pairs of y's, 6 pair of y's, 6 y's came out. Okay? On this next one, okay, the product rule is actually the same. We're just going to make it a little bit different. We're going to, this one is going to factor each part. Okay, so let's start with a nice one. If I had square root of 121, x to the 10th, y to the 4th. So the only difference between our first example and these examples is now that it's got multiple things. Oh, 121. That one is in my list. 121 is 11. So I could look at this as the square root of 121 times the square root of x to the 10th times y to the 4th, square root of y to the 4th. This is a perfectly good way to look at it because we know this one's 11. I tend to go like this. Oh, that's 11 times 11. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's, and 1, 2, 3, 4 y's. So here's my pair of 11's. Here's 1, 2, 3, 4, 5 pair of x's and 1, 2 pairs of y's. So 1, 11, and we know that square root of 121 is 11, and then 1, 2, 3, 4, 5 x's. So x to the 5th, 1, 2, y squared. Do I have anything uncircled? Anything left by itself? Nope. So the square root of 121 x to the 10th, y to the 4th is 11 x to the 5th, y squared. Okay, let's try another one. Let's do the square root, and this will be our last one. Let's do the square root of 72 x cubed y to the 6. Okay, so 72. I know 72 is divisible by 9. So this is 9 times 8. 9 is 3 times 3. And 8, that's a 3. 8 is 2 times 2 times 2. So there's my prime. Okay, x, I have 1, 2, 3 x's, and 1, 2, 3, 4, 5, 6 y's. Okay, I didn't leave myself very much room. Hopefully you guys did better. So I've got a pair of 3's, a pair of 2's, and then this 2 is lonely. There are no pairs. I have a pair of x's, and this one's lonely. I have a pair of y's, 1, 2, 3 pairs of y's. So let's look at this. I have 1, 3 that comes out, 1, 2 that comes out, 1 x that comes out, and 1, 2, 3 y, so y cubed that comes out. What's left? Well, a 2 and an x. So 3 times 2 is 6. So I have 6 times x times y cubed square root of 2x. Okay, if you have a variable, you can't really check it in your calculator. You could check the numbers. So I could take and check the numbers. I could do square root of 72, 8.48, and then I had 6 square root 2, which is the 8.458, which you can't see. So I could check the numbers, but my x's I can't check. Let me know if you guys have any problems with these. I'm more than happy to do more examples, and I hope you guys have a great day. Bye.